In this demo, we'll take a look at how we can use method overloading to improve our CalcEngine program. Here we are in our math equation class. And you'll recall that we created this with three constructors. One that accepts no parameters, one that accepts just the opcode, and one that accepts the opcode and both values we want to operate on. Now the way this works is that when you create the math equation, if you know the opcode and both values when you create it, things are nice and easy to use. But if you only know the opcode at the time you create it, and then later when you're ready to execute, you then have the values, we're a little bit cumbersome to use because you have to create with the constructor that accepts the opcode, and then you have to call set left val to get the left value set up, right? Call set right value to set up the right val. Then we scroll down here a little bit. Then finally you call execute. Well, it seems very likely that there'll be a lot of situations where we may create an instance of our math equation with a particular opcode, and then when it's time to execute, we'd have both of the values we want. So it would be nice to be able to go ahead and just pass in those two values as part of the execute. Right, so this is a great opportunity to provide an overload of our execute method. So we have the one currently that takes no parameters. Let's add an execute method that accepts two parameters, the left val and the right val. Right, so that's going to be really easy for us to do here. We're just going to declare it public void execute. And then we're simply going to have parameters for the left val and the right val. So we have both those parameters. Let's go ahead and put the body of it here. And all we need to do inside of here is set the field left val to the value of the parameter left val. Do the same thing for the right val. And then call the other execute implementation. And so now, in this scenario where we have the opcode construction time, but the two values at the time we're ready to execute, we can do that kind of all in one step. So let's go over to our main program here. And we've got the existing code that we worked with before. What I want to do first of all, before we do the actual work, I'm just going to put a couple of print statements in here just to print out a message in the output window so we can differentiate what we've done with the array previously with the new work we're doing with the overloads. Let's go declare a reference to our math equation class. We'll call this one equation overload. And what we'll do is we'll just new up an instance of the math equation with the dividing opcode. So we've got that there. Now before we use that, let's go and just declare a couple of doubles up here. So we have a variable called left double set to 9.0 and a variable called right double set to 4.0. What we want to do here is that go ahead and perform the actual calculation. Right? And as I said before, what we'd have to do is call set left value and set right value each time. Now it gets really easy. We just say equation overload. We'll say dot execute. And what we're going to do is pass in the two values, left double and right double. And then of course from there we can just go ahead and print the values out. So we simply call execute, passing in the values, and then go ahead and just get the result back as we print it out. Right? So if we run this, it's going to work just like we would expect it. And we see there in our output window, under using overloads, we see a result of 2.25. Right? So that works just as we had expected. But now what happens if, instead of using doubles here, I declare a couple of integers instead? So there's basically the same values that I had before with the doubles. Right? So if I copy these lines that we used with the doubles, and what I want to do here is where I have left double and right double, let's switch that to left int and right int. So now the question is, will that work? Since I've declared my execute method to accept doubles, I'm passing in ints, is that going to work? So let's go ahead and run it and see what happens. And we see that it does work, right? Is that our result with the integers is also 2.25. And the reason being is that that's what we call a widening conversion. Remember earlier in the course when we talked about calculations, how there were some automatic type conversions that can occur. Since a double is wider than an int, in other words, a double can hold anything that's inside of an int, the system can go ahead and infer that conversion and go ahead and call the method that accepts doubles, even though we're passing it ints. Now there is one thing that's kind of curious though, right? Let me just run this again real quick. Our result of dividing the integer 9 by the integer 4 is being printed out as 2.25. We remember that in our integer arithmetic that we learned earlier in the course, that should actually just be 2. When you divide two integer values, you don't get a decimal point. You only get the whole portion of that. So to make our math equation class more effective, what we should really do is provide another overload of execute that accepts two integers. So I'm going to go over here. I'm going to go ahead and copy this one that we have here now that accepts the doubles. I'm going to go ahead and paste that in again. And what I want to do here is convert each of these doubles to be ints. So we now have an overload that accepts integers. But now if we were to run this right now, nothing would be any different, because even though we're passing integers in at the parameter level, when we make the assignments to the fields, they're going to convert to doubles again anyway. Well, what happens when you do division with integer values, right? You get a truncated value. So what we can do here is that after we call execute, the value that's going to be in result would be 2.25. Well, if we could truncate that, then our math equation class would provide the right answer for integer division. So what I can do here is I can take my current field result, I'm going to assign it the value of result, but what I'm going to do here is cast it to an int. And what that does is it takes that double value of 2.25, by casting it to an int, it gets truncated becoming 2. That 2 then gets assigned back into result as 2.0 because, again, result's a double. So now what should happen is that when I go back to my program here, now when I run this second call to execute that passes in integers, I should get a proper answer for integer. And you notice now the result is 2. Now it displays as 2.0 because it's being stored as a double, but it's giving us the right behavior for dividing two integers. So let's go one step further now. So I'm going to go ahead and copy these same 3 lines here again where I pass the integers in. So I'll copy that. I'm going to go ahead and paste that in. So now in this third call, what I want to do is I'm going to go ahead and cast this first one to a double. So now what happens there is I'm now calling execute with a double as one parameter and int as another parameter. Well, which one's it going to select? Right? If I go back to my math equation class, if I look at my executes, well, I can't pass a double into an int because that would be a narrowing conversion. That's not legal. But I do know I can pass an int into a double. So the system will actually choose the one that accepts 2 doubles because that's the only one that can accept all the parameters. Right, so now if I go ahead and run this, we see we get 2.25 for that last one. The system had to pick the best overload of all those that were available, the one for which there was a valid way to pass all the parameters. In practice, the mechanism that Java uses to resolve method overloads is pretty intuitive. In most cases, it's going to pick the one that you expect. But the implementation of how that is resolved is actually quite complex because there's a lot of kind of nuances to what can go on. If you're interested in all the details of exactly how the system chooses a particular overload, I've put a URL on the screen that references the specification for Java on exactly how that works. It's really kind of interesting and it's actually quite complex, but if you're interested in kind of learning more about it, I encourage you to check out that URL.